Good morning, Tasneem. Good evening.
Good morning, Tasneem. Hello, Asta.
Hi, good morning.
How are you?
I am good. How are you today?
I'm good, good. I'm ready for the grand finale.
Oh, yes.
Okay, let me get ready here.
Hi, Reinhold.
Good morning, Tim. Good evening.
Hi, how you doing? Thanks for sending that that out in Word format. I had the Vice President of Technology asked me if I could convert it, but when I went to convert it, I needed to pay a subscription to Adobe.
Oh no, I usually share these documents as a PDF. I'm an Apple person, so I always use Apple products to create them, but it's easy to convert. So.
Yeah, well, it is easy to convert, but I think you have to have the original.
Yes.
To convert it, and I didn't have that, so I had to ask you to do that for me. Thank you.
That's okay. Are you still in the office, or is that a virtual background?
No, this is, I'm actually in the office right now.
Okay. 2 more days, 2 more sessions.
Yeah. Do we have a presentation today?
Yes, we do. The Future of Industries by Julian Velázquez. And I believe he's from DuPont.
From where?
The company DuPont. I don't know how you pronounce it in English. DuPont in French.
That's the French would say DuPont. We would say DuPont.
Okay, so let's say DuPont.
I'm okay either way.
Yeah. Tu parles français?
Oui, je parle français.
Ah, but you are from the eastern part of Canada, right?
No, but I lived for 15 years in the province of Quebec and was very active in Quebec politics.
Yes, yes. Hello, Julian.
There.
Or is it Julian?
Either way works.
Yeah.
So it looks like we're having some issues here. I think the original link was sending us something for tomorrow, so I'm letting Nancy know here. I'm just gonna get the link. There we go. Yeah, it seems there was 2 links. One was when we clicked it, it would say that the meeting was scheduled for tomorrow.
Oh, from Irina.
Yes.
So maybe she sent you.
Yeah, I just forwarded the new one over to Nancy here.
You asked about a colleague of yours, right?
Yes, she's our Innovation Center coordinator. She'll be present for most of it, I guess.
Okay. Where are you based?
So I'm out here in Sunnyvale, California, right in the heart of Silicon Valley.
Okay, I'm in the foggy part of Silicon Valley in San Francisco. So.
Oh, there you go. It's a foggy day today.
Down there as well?
Oh, yes.
Yep. It's still foggy.
Yeah,
Good morning,
I'm hoping
Mrs.
it's
Nancy.
fun. Oh, there she is. Hello, Nancy.
Is that Nancy Lima?
That is me. How are you?
I'm good. Good morning, Nancy.
Good morning.
So give us a few more, 2 or 3 more minutes until more people come in.
Sounds good.
And then I'll hand it over to you.
Wonderful. Getting my desktop here ready. There we go. All right. Well, it's great to meet you, by the way. All of you that are online now.
Absolutely.
And Nancy, are you also in Silicon Valley or are you based somewhere in the Middle East?
No, I'm actually here with Julian, Silicon Valley as well.
Okay. Okay. Good morning, everybody. Good evening, I should say. I still say good morning.
Good evening.
Hope you had a good start into your week yesterday. We're starting our week today or this morning. So good to see you all signing on. I'm going to wait a minute, maybe 1 minute more until we have more people online. And then I'll hand it off to our guest speaker. Okay, I have 8:05 here on my clock, so let's get started. Again, good evening, everybody, and delighted to have Julian Velázquez and Nancy Lima from DuPont. join us today to give us a glimpse into the future of industries. Very much looking forward to that. And without further ado, I'm going to pass it on to you, Julian.
Yeah, well, thank you. And hello, everybody. So my name is Julian Velasquez. I lead our innovation center out here at the DuPont Silicon Valley Technology Center, along with Nancy Lima. And like we said, we're going to take a look a little bit about future industries. We're going to give you guys a quick tour of our site and how we're developing our digital competencies in order to be able to handle future businesses and such interesting times that we're in, as well as give you guys some quick focus areas on where we think a lot of industries are headed and how we're preparing to tackle those future needs. So it's going to be a rather interesting few-minute tour here that we have set up for you guys. You'll be one of the first to experience this for not just for us, but in general. We've been sort of digitizing our space in order to be able to provide these tours. Had this been different times, we would have loved to have had you in our innovation center, be able to give you a quick glimpse of what we're working on and what capabilities are. But because of that, we've transferred over to sort of a virtual space. So please bear with us as we sort of maneuver our new virtual space. So I'm going to go ahead and present my screen here and make sure I have everything ready to go. And I think that's perfect. All right. Let's share screen. All right, so we'll start off with a quick video here. Oh, actually, I believe I need to share audio. Here we go. We're normally a Teams-based company, so don't. All right. All right, so without further ado, welcome to our site.
Hi, I am Jake Chu, Technical Manager at DuPont. Welcome to our Silicon Valley Technology Center. This dynamic hub houses 10 state-of-the-art applied engineering labs, our signature innovation center, and many flexible meeting spaces all under one roof, and all ready to welcome and support our partners, current customers, and potential customers. Our immersive facility is designed to show our visitors the full scope of our expertise and capabilities, and to highlight our local and global network of scientists, chemists, and engineers. Our experts are passionate about addressing our customers' most pressing needs and solving their problems in innovative and environmentally conscious ways. We believe that material science is an essential part of achieving a truly sustainable planet and society. We see a future where all materials and technology are safer by design. Our goal is to ensure 100% of our products and process adhere to sustainability criteria, including the principles of green innovation. We are committed to developing highly durable and reliable products that help humanity thrive. Come explore the Silicon Valley Technology Center and learn how DuPont is creating the essential innovations that the world needs now.
So that's just a quick introduction there from our technical manager, Jake Chu. And so, without further ado, I'm going to show you a little bit about our site. So we've developed like I mentioned, a quick virtual space here to be able to walk through guests in a virtual space, and then be able to really introduce a lot of the work that we're doing here. And so without further ado, I'm going to go ahead and walk you all here. And at any time, I encourage y'all, please interrupt, ask questions. Really, we've developed this with the intent that we can continue to have one-on-one interactions in an open space and have open dialogue. So I'll go ahead and I'll talk a little bit about what you guys are looking at here. So, and I'll give you a little background about our site, DuPont. So for some of you may be aware, DuPont's been around for over 200 years. Quite frankly, the United States probably wouldn't be the United States had it not been for a lot of the work that DuPont did very early during the Revolutionary War. And so we've expanded. We're a material science company that focuses on, well, we like to say we build everything for anything. Our site, specifically at DuPont Silicon Valley, we have though we do represent the entire portfolio, our focus is mainly on the electronics and imaging, electronics consumer-based products. We mainly focus on semiconductor development, as well as other smaller fractions of electronics materials. So what you're looking at here is we're still under multiple phases of construction. The site has originally opened in 2018. Originally, there was a merger between Dow and DuPont. After that merger, we split into 3 companies: Corteva, which focuses on agricultural sciences and biosciences; Dow, that focuses mainly on the classic chemical development materials; and ourselves, DuPont, focused on specialty materials. So we'll go a little bit over the portfolio and how we're handling and how we represent each one in a few. But what you're looking at here is really a community space. We've developed this space to have people come in, be able to relax, put down their items, and really developed an open sort of a WeWork space, Starbucks, if you will. It's still under first phases. The next phases will be happening towards the beginning of next year. And so what we'll do here, this space as well will be the initial opening for the Innovation Center. However, like I said, we're still in the construction. Most of this has been completed. And so I'll talk a little bit about what we have here. So in general, we have about 6 rotating digital pedestals. Had you been here, you'd be able to go in and tap on each one of these, go deeper into each one. We developed these to focus on 6 different areas that are big focuses for us, and how we anticipate current industries to become informing and having different needs and wants. So further out here, you'll see a jacket. Seems like a normal jacket, but it's actually a heated jacket. It's a very thin material that's woven into the jacket, made out of silver inks. What's very unique about this specific jacket is if you go back and you take a look at the 2018 Olympics in Pyeongchang, Korea, this was the same jacket that our US team was wearing. Most of the teams there were bundled up, but our team was wearing just this one's because it is a heated jacket. That same material in Texar. It can be used for smart materials, smart clothing. We've used that to create various pieces of athletic clothing, as well as a product known as the Outlet Band. That in 2019 actually won CES Product of the Year. It's basically a sock that the mother will wear around her belly and expand throughout the various terms of pregnancy, and used to capture different vitals from the fetus and the baby. Movement, contractions, breathing. So a very unique product, but what's very unique about the material itself is that it can be used as wiring. In this case is what we did, but it is a stretchable, conductible ink. Furthermore, we'll talk a little bit about here. This will probably make more sense once we go further into the slides. But this is our plating metallization pedestal. A big focus for our site is Kapton Pyrolux. It is a copper clad based material used mainly for wirings and cell phones. It can be used for heating as well, and data transfer. I'll go over here. Further back, what you'll see here, we have these 2 products, a drone and a pair of AR goggles. DuPont being a material company, very difficult to sort of showcase a lot of our materials. Sometimes it'll just be a can of ink, for example, or a sheet of Pyrolux. It does not tell a very good story. So we partnered with the local design firm, mechanical engineering design firm, 219 Design, and we tasked them to help us better tell our story so that we're more prepared to showcase our materials and their capabilities in such an advanced place like Silicon Valley. So we came up with these 2 devices here, a pair of AR goggles made of about 60% of DuPont materials, and a drone that actually does fly, made up about 80%. If you were there, you'd be able to feel the materials, see the tactileness, and understand how each one is made up. I won't go too much into detail here, but the feet, for example, are made of a material called Hytrel. It's very durable, but it's 3D printed. So you would actually feel the ridges, but could bend it almost all the way through without any fractions of snapping. Very unique material, very durable. So we use it as a landing pad. So when the drone lands, it absorbs the impact very nicely. You'll see here on the next slide, a basic cell phone here. Basically, it was developed to showcase all the different components and materials that we are able to do when putting into a cell phone. More likely than not, whatever phone you're holding has a good amount of DuPont materials within it, whether you know it or not. And then, of course, we have our sustainability pedestal here. We'll talk a little bit more about our sustainability factors here. So I'm going to go back and switch back to the presentation here to show you a little more. I'm going to skip this one here. So again, we wanted to talk a little bit about the center itself and how we're using the center to better address our customers' needs. Aside from being a open space where we can host events and have people come in and experience our materials, our team is dedicated to further developing DuPont's digital capabilities. And so part of our team has developed this experience that you're going through here. We've developed a lot of digital content like what you're seeing in the pedestals, but even furthermore, expanding DuPont's capability to explain their portfolio. We have thousands and thousands of materials. We have thousands of very intelligent scientists and engineers. And at times it's been very difficult for a company as old as DuPont to be able to express that and be able to communicate, market, and campaign a lot of the materials and the capabilities that we have. So our team being one of the, if not the pivotal point of innovation in the West for DuPont, which has historically been an East Coast company, we're tasked to develop a lot of these digital competencies and components. We manage a lot of the social media. We also host various seminars. So I encourage that if you have more interest in learning about our electronics division, to subscribe to our YouTube channel. We'll send you, we host seminars on a monthly basis, and we partner with various leaders. Most recently, we had one with Optimind. A while back, we had some speakers from Microsoft and IBM come and speak, and we would host the event in a virtual space. Ideally, this would be in person, and in due time, we will bring that back. So there's a lot more that happens through our innovation center and our abilities to showcase DuPont's capabilities. The other part of our team and in general was the DuPont, and I'm sure many of you are aware, is that our customers are moving to a more greener solution for their products. We, as a company, as a material company, have recognized this and have therefore dedicated our resources to ensuring that future products are developed with reasonable, responsibly sourced materials, with the principles of green chemistry, and doing as much as we can to ensure that our materials are of a renewable source. So in our site, we've developed a team that's primarily focused on this here. And so what we've done is we've converted all of our labs, all of our office spaces in Silicon Valley to 100% renewable energy, powered by wind and solar. We've made strides to ensure that we're doing proper composting, and then ensuring that we are removing our hazardous waste in responsible ways. And that is a very small print of what DuPont as a whole organization is doing. But our site is very, we're a site of about 55 employees roughly. And so there's this is the efforts that we're putting in, but as an overall organization, DuPont is ensuring that new upcoming materials are developed with green chemistry, green innovation in mind. So our labs, I'm going to go back here so you guys can see more. I'll finish up a little bit on this area. This is another big focus for DuPont as we see automotive, vehicles in general becoming electrified. We wanted to showcase how our materials are used in various automotive applications, and that will enable future electrification for vehicles. So a really great story here, I'll just point to this one here, is the underbelly of a Ford F-150. Some of you might have recalled that there was a good chunk of time where these pickup trucks are made of steel. Ford decided to switch to aluminum to allow for a more lighter platform, which would later allow for the new electric F-150, the Lightning, to come out. What happened was when Ford switched to this new aluminum platform, they recognized that it's not as easy to weld aluminum than steel. So they came to us and we partnered with them. We basically introduced a product called Beta Seal. And in this product here, it allowed us to just basically adhere a lot of the products, a lot of the underbellies of this car, and therefore allowing for much lighter and much more durable structure. You'd be surprised now how many cars out there aren't welded, they're just glued together. And so we provide a lot of those materials out there. So I'm going to walk you through a little bit of the lab space here. What you're looking at here is what we we call our Flex Auditorium area. This is where we would host various industry day events and allow people to come in and communicate, have networking industry day events, cocktail hours. Unfortunately, we opened and had to close very quickly. However, our first year alone, we saw about 2,000 people walk through our doors and experience our lab spaces. So quite a lot of traffic. So I'll talk a little bit about this lab here, but we'll focus on other ones. So in all, we have 10 application labs, all focused on, we're not an R&D site. We do not develop materials here. However, we use our sites to characterize, test the different capabilities of our materials. And to a degree, we will formulate some new materials to better meet our customers' needs and requests. However, again, you're not going to come here and see a new product of the future being developed here. That is more for our DuPont site that is headquartered, our official headquarters out in Delaware, where we have what we call the experimental station. That site itself there is, well, I don't know how many buildings, I believe about 33 buildings. It's about the size of a university. That's where you'll go and you'll see a lot of our scientists working on future products and things of the like. So this lab here, I'll touch very quickly on. This one's really focused on characterizing a lot of our materials. We do have a class 100 room here to support a lot of the different materials that require a very clean room. So we have peripheral meters here and others. So there's some videos I'll show you a little later to understand what you might be looking at. So here's another one of our labs. This lab is also a little more focused on the actual development of specific materials. So we have inkjet printers, gas and heat chambers here, presses. This is really to just sort of, again, formulate some of these specific materials that we might be working on. Again, mainly we focus on Kapton, but we do have other materials such as our Intexar and our 3D printed materials that will be put to the runs here. So this lab here is our characterization lab. This one focuses on doing various, I would say, unique tests, I guess you could say. So we will put our through high pressure here, our materials through water testing to see how soluble, non-soluble they may be. We have a DMA here, which will put it into high pressure. A lot of our materials will end up in space. If you've seen the rovers out on Mars, you ever see those gold blankets all around the rockets and the rovers themselves? That's our materials. A great story was the last two rovers, Spirit and Opportunity. I believe they were only supposed to be out in space for about 5 years, ended up lasting 15. And if you see pictures of how they are now, everything that's still intact is DuPont material. So we like to tout that out quite a bit. But let me show you a little bit about this optical analyzer here to get an idea of the kind of work that we do.
Hi, I'm Claire, an engineer at DuPont. We're here at our Silicon Valley Technology Center, where we design and test innovative new materials for companies of all kinds. Our work here makes some of the most cutting-edge products on the market possible. The natural world is incredible, and we often take our cues from nature when we are designing new materials. For instance, we might want to design a film that repels water like a lotus flower, with water beating off effortlessly, taking all the dirt in its path with it. Or we might want to create a material that allows liquid to easily evaporate, much like sweat off human skin. When we want to test how well a liquid will adhere to a material, we use this machine. the Optical Contact Angle Contour Analysis System, or OCA for short. With the help of high-resolution optics, exact liquid dosing, and precise sample positioning, the OCA can measure the contact angle where a liquid meets a solid. This contact angle tells us how hydrophobic or hydrophilic a material is. That is, whether the material repels water or spreads and disperses it. Let's look at how the OCA works. Here, we have the dosing unit and the syringe that holds the liquid we'll be testing. And this is the sample stage, which moves up and down to ensure the droplet makes contact. Finally, we have the optical camera system, which is able to see the droplet on a horizon line with the help of a light projected from the other end. All of these functions are controlled by an interface on this computer. When I want to perform a test, I can release the liquid and observe how the liquid and substrate interact. We get a live reading as the software translates the measurement of the contact angle. Although we can take our inspiration from nature as we create materials, actually producing them takes a lot of experimentation and testing. The OCA is an important tool in designing the high-tech materials all around you. Here at DuPont's Tech Lab, we understand just how much the small details really do matter.
That's just a snap of one of the many instruments that we have in our lab. So I'm going to just quickly walk you through the other labs that we have here and start to focus a little bit about what exactly our customers are asking from us. So we've talked a bit about Paralux, Kapton. That really ends up working, at least for us in many cases, as wiring and cabling, very thin wiring and cabling for various devices, cell phones, computers, and whatnot. As things get smaller, and lighter, the use of regular cabling, it's just not going to cut the needs of many of them. So we'll use a lot of these labs to test out strain, durability, data transfer for specific materials. I'll walk you guys through here real quick. This is just our kitchen. There's a specific lab that I think will catch a lot of interest for you all. So this is our RF signal integrity lab. So many of you are aware 5G is a very big thing. We've started the rollout of 5G. We're looking at 6G, many companies. But a lot of things folks might not recognize is the type of materials needed for these materials. So specifically 5G, if you've noticed, if you've been able to travel to major cities, you'll notice that your 5G connection isn't as great as if you're in open space like out here in California. And the reason for that is signal integrity. 5G being a millimeter wave, very tight based wave, doesn't play well with conventional structure materials. So the material, the wave itself won't pass through specific materials. So we've invested quite heavily in this lab specifically. It might not be the flashiest looking one that you see here, but this lab itself here is worth millions of dollars just based on the materials themselves. I had a slide that I couldn't find that was comparing each one of these to a luxury vehicle, just in terms of cost. This right here called the VNA itself is about the cost of, I believe it was a Ferrari 420. In terms of cost, it's a $1 million product and instrument equipment here. It's used to test signal integrity on specific materials, how well millimeter waves will travel or transfer through a specific material. In this case, it being Kapton, but we've used it to test out other materials such as Tyvek and Nomex. But the concept behind this is to understand how well materials could function as antennas, how well they can function as building materials for future buildings and skyscrapers, so that we can allow these waves to transfer through and be functional. We've seen that the higher waves, the harder it is to do this. So a lot of the testing happens here. This type of equipment you're seeing here is far and few. I believe the VNA here, there's only about maybe 4 or 5 being used in the US. So we're very proud of having this and having the capabilities to handle such equipment. This one here is a rather small lab, but it's our UV laser lab. So we use this lab to etch out different chips and vias on a specific wafer. Very unique, very fun to watch. And then here we have another fabrication lab. We will work on OEM. It's just basically an OEM press. This machine here will slide through a piece of Kapton, Parallax, and imprints whatever sort of vias and connections that we might need here. That's a very unique lab. I'm going to walk you through one last lab here, one of our newest ones. And this one here is called the garage. Now, something else that we pride ourselves in and that we've learned very quickly while coming into the Silicon Valley was the speed required for a lot of these materials to be tested and then returned to our customers. We'll have someone come out and it used to take several days to get something shipped out to us. And by this, it might be a specific shape, say a shape of a cell phone. And so that would slow down the prototyping process. Ourselves, as a site, we can turn around prototyping tests within about 24 to 48 hours, very quick. However, getting some of these materials and sizes and compacts and shapes could take weeks at a time. So we developed this lab to be able to mill out specific structures and shapes. We've invested in training for our engineers to understand CAD development, CAD design. So we also invested in a CNC mill, various 3D printers to be able to just quickly ship out, print out, or mill out any sort of shape and material. I'll show one last video here and then we'll go to something else.
What draws the world's most talented people?
This is well, I apologize. It looks like it's still not updated. So like I said, we're still developing this. You guys are the first to see this experience. So in all, that is our space. I'll switch back over to the presentation and go a little deeper as to what sort of materials and industries we focus on, not just at the Silicon Valley, but in DuPont overall. And again, at any time, please feel free to ask questions and stop us here. So again, just a quick bit on our labs. We have 10 labs. We're looking at developing more. They're focused on characterization, reliability, formulation of various materials and properties, fabrication, and a bit more like you guys saw. So our overall focus, minimize this here. So like I mentioned, at DuPont Silicon Valley, we do have a bias towards developing and focusing on our electronics portfolio. So multi-material system integration, electronic convergence, and digital acceleration. So what do these things mean? So for multi-material, you're noticing, like I mentioned before, our customers and the future of a lot of these industries are really looking for more durable, more reliable, and higher performing products. Again, mainly on the network and millimeter side of things, these sort of materials are key. And without them, the acceleration and moving forward to these sort of high frequency, high network based products, it's just impossible. I will talk about cars, for example. So you saw that we have that area focused on automotive. If we really want to reach a future where cars are able to self-drive and communicate, the data transfer and the data rate between vehicles is going to be massive. And in order to do that, we need to be able to develop these materials that can handle the data transfer that's going to be required for self-driving vehicles. In terms of electronic convergence, again, it's increased power and density and frequency, but while miniaturizing. So a big focus for us is miniaturization and making sure that we are developing the materials to enable miniaturization and be able to, our phones are getting smaller and smaller. That's a very typical thing. But if you think about something like wireless headphones, for example, that I'm wearing here, the size and chips of these devices have shrunk by hundreds of multiples, including the batteries themselves. So we do have some battery development here to allow for higher performance while not, I guess in the case of your headphones, blowing up in your ear per se. Some of our materials that don't fall under the E&I portfolio, fall more on the construction side of things, do complement. So we do cross industry lines within DuPont to develop full package products. So I'll take a quick example here. If you are familiar with Nomex, it is, so for all intents and purposes, a household name. Nomex is a material that is fire retardant. It's used for the uniforms of F1 Formula racers, for example. But we will combine that material and weave it into various lithium cells for cars, and in many cases drones, for example, to ensure that if in the case of some sort of fire runaway experience, it does not blow up. So it's a combination of our E&I materials and our safety materials as well. And lastly, digital acceleration. So this sort of falls back into the multi-material system integration. Things are getting smarter. And because of that, that means more computing power. So a lot of our materials is focused on not just the chip themselves, but the data centers themselves. These data centers require a lot of cooling, a lot of thermoregulated materials. Some of you may be aware that we recently acquired a company known as Laird that mainly focuses on thermal distribution for high frequency data chips. So that's a big focus for us. And I will say, in general, I think it's a big focus for the entire industry as a whole. You'll notice that as we build more data centers, we are producing a lot more heat, a lot more energy. Our phones themselves are because of the amount of computer processing power that these phones are put through, they get hot. If you've ever had that issue where one of your phones says, hey, you need a break because it's too hot, that's going to keep happening unless we continue to develop materials that allow for thermal dissipation and allow for quicker cooling. So we do develop various pastes, various forms of Kapton to mimic graphite, which will allow for thermal dissipation from a battery, for say, or a computer chip. So again, here's a quick overview of what we are focused on as a whole for DuPont. In Silicon Valley, we do focus on quite a few of these. I'd say really the health and medical and the manufacturing and industrial side of things, we do not participate as much in. However, on occasion, we will have guests come in so that we can connect them to the broader DuPont. We are a connection site after all. You'll see here, so things like government and public sector. I don't think it's secret. We do several things with the government. We did develop Kevlar after all, but there's more to that. I'll touch a little bit on healthcare and medical. If you all recall, during the I'd say mid times of the peak of the pandemic, we were mentioned by U.S. President at the time, our focus on developing healthcare packaging. So we worked very closely to get a lot of the packaging necessary for medical products, injections, specific, I would say, pills, if you will, and making sure that they were protected and during transfer and development. Other things that we're focused on, again, aerospace. I think that's also a pretty a given. If you ever in a plane again and you touch the walls of the plane, I'd say 99% of the time you are touching a DuPont material that is called Tyvek. It is very easy to clean, very durable, hypoallergenic, non-porous. So again, we pride ourselves in saying we build everything for anything or anything for everything. In all, as a material science company, it's our goal to advance human civilization. It's our goal to keep us safe and allow us to be able to move to, I'd like to say, a higher state of mind with electronics, medical materials, and our construction materials. So in all, I'd say thank you. That was a quick tour and a brief overview of our site and how we see many of our industries and our customers moving forward. So at this point, I'd like to just open it up and see if anybody has any questions, would like to know more about our site, or myself or Nancy here.
Thank you, Julian. Was a lot of walking.
Yes. it's a fun time. I wish, you know, originally when we were setting this up, we had the intent to have you all come out. I think it would have been a much different experience. I would have loved to have seen you all touch. We'd be handing out samples, and really giving you guys a world-class tour and event.
Any questions from the group? Any thoughts, reflections?
So I have a question for the group. This is Nancy Lima, the Innovation Center Coordinator, and I partner with Julian. Being that you can't be here, you couldn't be here, how was that tour for you?
That's a great question.
It was touchless.
Touchless. That's great.
And I think it was actually one of the questions I had or thoughts. Since DuPont is focusing so much on material science, and seeing and touching is so crucial, what is being lost from your center's vision and mandate as everything moved online?
It's a wonderful question, and I'm glad to say that we've learned a lot and figured out quite a bit. So the touch and feel side of things, though necessary, we learned that we could still have business. We could still work with our customers when this. So we as a site didn't shut down because of we were deemed essential for all purposes there. And so we were still able to have our engineers on site. We were still able to work with our customers. A lot of the products that we do develop are deemed, you know, essential for society. So that didn't slow us down too much. However, what did slow us down was we had some programs out of the Innovation Center, one called the Design Bar. I unfortunately didn't get to show you that there. What we learned as a company new to Silicon Valley was that designers are key. And by designers, I mean design firms like 219 Design. There's various others in this space. They function as the middleman for a lot of these big tech corporations that are our customers. These tech corporations will go to these design firms and say, hey, we're developing a speaker or we're developing a phone. They will then develop these sort of materials, and they will develop the product based on whatever materials they might have on site. We developed a program called the Design Bar that was made to go to these design firms and just drop the Design Bar, which is a rather rectangular cabinet with our materials filled in it. We developed an app where people could scan the box and bin and get to understand what sort of material they have, and they'd have the material in hand and then communicate back to us, and we'd therefore be able to get built into that specific product. Very quickly mention how that worked there, but that program had to stop because for obvious reasons we couldn't go to these sites and speak with our customers and have that one-to-one interaction. So it took a hit. We had to stop those programs, but we've developed them digitally. We're working on various digital experiences to be able to develop and explain a specific material, and then therefore we will send out the materials via mail or sample, what have you. That's another reason why we spun out our seminar series to go into the technical aspects of a specific material. And I think what helped us out, to be quite honest, is that we weren't the only ones in this situation. So we noticed there was an immediate need for this. So on average, our seminars will have over 200 people with upwards of 700 to 500 people attend. And then various views later on when they're uploaded to YouTube. So I hope that answers your question there, but we've had to pivot, but because our customers had to pivot as well, we were sort of able to meet in the middle there. And now that we are opening, we still are, we're able to have some people on site and do things like that. But thankfully, we weren't alone in this.
Great, thank you.
I think someone had their hand raised a while back. I don't know.
Lena.
Lena.
Thank you. Thank you, Julian, for this tour. It's interesting to see where all the magic happens. I have a question. Since the company is well known for their innovative products, and it is always, this is something, it's a pattern that we see with innovative companies, that investors will be excited and a lot of money will be raised, and then discipline in with regards to allocating the funds could be a little bit difficult to control. So I see that you have invested heavily on the labs and programs and seminars. So how would you describe, or not describe, quantify the rate of return on this investment?
I love this question. It's something we always get asked. So I'll speak a little bit for what DuPont's doing, and then I'll speak a little bit about what I've done in the past to be able to quantify, I guess you say, our ROI, if you will. So at DuPont, we are rather new. And technically speaking, though we've been open for 3 years, we've only really been open for about 1.5 years. Because we launched that late 2018. We had roughly a bit of 2019 to go by, and then shut down. So in that short run of 2019, the way we were still learning as an organization as to what it meant to have an innovation center in the West Coast. So we took very high level metrics: how many visitors, how many projects spun up, how many new relationships were created. So at a very high level, very quantifiable metrics, that's how we sort of quantified and gave purpose and justice, if you will, for the amount of money invested into it. What we later learned was that that's not the best way to go about it. DuPont, again, I'll say, is an older organization, so a lot of our infrastructure internally in terms of customer management and lead development and generation is a little convoluted. We're getting better at it. And so what would happen was, just it's hard to quantify the conversations you have outside of work. And that was a big thing for us here. And I think it's a big thing for Silicon Valley in general, is that a lot of business will happen outside of the office. And then we'll bring someone in and we'll have a sort of conversation, it'll go away. And then maybe a couple months later, they reach out to someone else in the organization. And so what we noticed was that we saw an immediate increase in customer demand. And therefore, we took that as a big win. We were lucky in that we had an immediate customer demand. Many times innovation centers in the past that I've developed and worked on, it takes a long time for people to even recognize that it's there. And so for DuPont's sake, we were sort of lucky in that. We also built this site because we had customers out in this area. And we learned that it's difficult to be developing and sending materials back and forth and things like that. So that in itself was already a win. I think moving forward, what we're working on is to be able to track projects, to track how a customer interaction goes from, just hello, how are you? This is what we do, to, okay, let's try to test something. And now let's actually put it into, a consumer product. And that process takes months, if not years. So that's something we're trying to develop. In previous organizations, basic metrics, that was one way to quantify it. But it stems down to the same thing, is how can you prove that what you're doing is going to lead to a project, is going to lead to interest. And thankfully, the last company, which was Lennar, we were able to build a pretty robust customer management system that would allow us to pinpoint every single interaction that a customer's had with us, as well as our partners and firms. So in all, I think that is where we're headed, but it's much harder said than done.
Thank you.
You're welcome.
Anyone else? Julian, I'd like to just piggyback on Lena's question. So you mentioned earlier that the DuPont Innovation Center is a showcase, a connection space, but you also have some application labs, but it's not an R&D, it's not one of the classic DuPont R&D labs.
Mhm.
So what is the main purpose of having that innovation center in Silicon Valley? Is it marketing? What is it?
So it's a mixture of all that. It is marketing. That is for one. So historically speaking, DuPont is an Eastern company. You go up and down the Delaware River, it's all DuPont. We come to Silicon Valley, people think we do paint. They still think we're a paint company. So one is marketing. All right. Two, it's being that doorway to the overall organization, and not in terms of marketing, but in terms of material development. So like I said, prototyping, Silicon Valley works quicker than any other part of the US, right? And so we learned that we were losing customer confidence and losing customers in general because we weren't fast enough. So now we have tech companies 2 miles from us that will walk into our labs and will hand deliver a specific product to allow us to test right there and then. So going back to Lena's original question, that's another ROI that we're looking at. Is now we're quickly able to work with our customers and be able to turn around. They'll come in and we'll have test results for them within the following day. It's huge. And so normally that would take a week's time at most, because you would have to ship it out there, and many times customers don't feel comfortable sending out something that's potentially very confidential. So that's the other piece, and then the last one is just development. So we developed the Innovation Center as a whole to be able to standardize a lot of digital communications, digital products and development, like what you guys saw today. We're a test hub. We're very much a test that's for the last year and a half proven to be very successful, which is why we continue to invest in it.
Thanks.
Yeah, I'll add to that one thing. The other thing that we do at the Innovation Center is, because DuPont is so large, a lot of the capabilities that we have across DuPont can get lost with Silicon Valley customers, right? So the other part of our role is when a customer comes in with an issue or a problem, that we can find the right people to connect them to.
Yep.
Even if they're not based in Silicon Valley. We usually have someone that can help solve their problem,
Yep.
their issue, and make that connection there as well. So we serve as that connection hub across DuPont as well.
That's a great point, Nancy. Thank you. Yeah.
The reason why I asked this kind of obvious question was the program that we're all part of is around design thinking, human-centered design, and one of the key aspects of this design approach is the proximity to the user and the customer, and really being able to understand the needs and being with the customer in the context. And so I assume location matters still in the digital
Absolutely.
era. And one of the reasons, again, I'm saying the obvious, one of the reasons why you decided to have a presence in Silicon Valley is focusing on the proximity and on the ability to understand your customers.
Yeah, absolutely. We used to have a map that laid out all of the customers we had, and we're within 5 miles of all of them. So you're right on the nail on the head there. It is proximity. It's a big thing for us.
And
while you were talking,
and along those things, also what you mentioned, this whole mindset of rapid prototyping and the tangibility of the prototypes, et cetera, et cetera.
Yeah, exactly. And you were mentioning things like design thinking and things like that. But that's something we've implemented quite heavily at our site. to not just when it comes to product development, but to a lot of the work that we do output. So a lot of our digital products and things like that, we will do analysis of our customer base and things like that. We actually used to host quite a few design thinking sessions focused around material design. So we'd love to have you all come by once we open that back up again.
Great, thank you.
We got 5 minutes of any other questions, or we'll wrap up.
There is Helena.
Thank you, Lena. Yeah. All right.
Do you have a question, Lena? Your hand, did your virtual
No,
hand was up?
she was clapping.
Oh, clapping. Okay, okay, good. Are you having other similar innovation centers around the world, or is this the first? And is that the first prototype?
No, so we have 9 across the US that have different areas of focus. We happen to be the one that sort of leads a lot of the development in terms of digital. But our main innovation center was just developed about 8 months ago out in Wilmington. That is a much sizable one, but it's more of a showcase and less of the application developments. It's actually in our experimental hub. We have another one in Auburn Hills. That one's in Detroit. So for obvious reasons, more automotive focused. They recently finished construction and will be opening, I believe, at the middle, if not beginning of next year. We have ones in Turkey, Japan, and Russia, Geneva. I'm probably missing another one there, but we're 9 in total with various focuses, things like that.
Right. One of the reasons why Silicon Valley exists is are the universities and the research, the basic research coming out of universities. There are other reasons why Silicon Valley got started, the weather, the culture, and then there are some secret elements of this magic sauce. But how is can you describe a little bit the collaboration between your center and the academic research in Silicon Valley?
Absolutely. So we actually had pretty strong ties with Stanford. For obvious reasons, we slowed that down. They actually were some of our guests that would come and do innovation-based conversations and discussions. We held various design thinking sessions with Stanford. They came out here to our site. And we held the sessions there. We had Dr. Cheshbro, if you're familiar with his work and innovation. He's a Stanford colleague, came out and had several discussions, even had a book signing at one point for a grand opening here. And then in terms of what we do, we partner with companies like NextFlex to work with STEM-based students. We'll provide STEM days for them to come to our site, work with an engineer, and do various tours. Nancy, I don't know if you want to talk a little bit about our work with Avid and mentoring as well.
Yeah, and so we also have 2 community-based mentorship programs that we're running right now. One of them is a partnership with Revolution Robotics, and they develop STEM kits, robotic STEM kits for the younger school-age children. Yeah. And we are currently in the process of partnering with a local school that is lower socioeconomic schools, so that we can really get into and touch those younger generations, right, that don't have the opportunities that others would have. So we have a diverse group of kids that we can reach out to and get them engaged early and interested in STEM careers, and plant that seed. So we have that program going. We also have a mentorship program with a local high school that we partner here with in San Jose, and we have taken a handful of mentors from our site, and we mentor high school kids. Again, each one of our mentors takes one student, high school student, particularly a junior, and mentor them as they kind of walk through their college journey. And AVID is a very specific program. Again, it's for low socioeconomic. They're generally students that are the first to go to college in their families. They are low represented backgrounds. So again, providing those opportunities for a group of students that normally wouldn't have the resources that we're providing. And we hope to sort of invest in them and see them further their careers and education.
Yeah, I love that outreach to that particular K-12 or education population. That's fantastic. Yeah. Okay, Julian and Nancy, thank you so much for the tour and the overview and reminding us that DuPont is almost in a lot of things we touch on a daily basis.
Yes.
And again, thank you and have a wonderful day. And we'll take a 10-minute break and I'll see you back in 10 minutes.
Thank you. Great to meet everybody.
Thank you for having us.
Bye-bye.
Thank you. Bye-bye.
Take care. Bye-bye.
Okay, everybody, welcome back. If you are back and could turn on your camera so that I know, that would be good. I see Dima. Anyone else back? Okay, sounds good. So second but last session tomorrow is basically the presentation, the team presentation. And we still have a presentation by, let's see, I think Intel. Intel is going to share with us their thoughts about IoT, the Internet of Things. But the main event for tomorrow are the 4 team presentations. And today is very easy. I want you to basically polish your presentation. And as I mentioned in Slack, but also last week, I really encourage you to do a practice run, 1 or 2, virtual practice run, not just thinking about it or talking about it, but doing it. Based on my own experience, and I do a lot of presentations, I still sometimes feel that I should have done another trial run for a keynote or so. It always helps. So what I would like you to do today is use the time to do a practice run. If you want me to sit in as you do a practice run, I'm more than happy to do that. If you feel that if you've already done a practice run virtually, not necessarily face-to-face, though face-to-face is always good, but in this case, your presentation tomorrow will be virtual, so it would be good to also practice it virtual. Who is running the slideshow? Who is going to talk? How do you make the transition from one part of the presentation to the other, et cetera, et cetera. So today is the opportunity for you to do that. If you feel you've done it, if you want to leave early, that's fine. You don't have to stay here until 9 o'clock. Just let me know if your team leaves early. And that's basically what I would like you to do today. So is there any team that would like me to sit in as you do a practice run? Abir, you have a question or?
Yes, we would like if you can see our presentation.
Okay, absolutely. So I put down team number 1 as the first team I'm going to visit. Any other team that would like me to sit in as you prototype your presentation?
Yes, please. You can join us in team 3.
Okay.
Show you the flow of the presentation.
Sounds great. I'm going to put down team number 3 as the second team I'm going to visit after team number 1. If the other teams if you want me to sit in, I'm happy to do so. Okay, I'm not going to push this too much. I'll be here. So if team number 2 and number 4, if you want me to sit in, just let me know. I'll be around until 9 o'clock your time, and happy to give you feedback or just sit there. No, not just sit there. I will give you feedback. And a final reminder, I shared this again on in Slack. So these are the things that we're looking for in your in your 12-minute presentation. And these are, I also shared these what should I call them? Learning objectives or outcomes. I also shared these with the members of the panel. So they will, as they watch your presentation, they will also keep those categories in mind as they observe your presentation. So do make sure that you address those learning outcomes in your presentation. Okay, so without further ado, I am going to open up the breakout rooms, if I can. Should be breakout rooms. Here we go. And team number 1, give me 2 or 3 minutes, and then I will join you. I'm going to give you a couple of minutes to get organized, and then I will join you in your breakout room. And after that, I will join team number 3. Okay, sounds good. So here we go. Good night, everybody. Asta, thank you.